Welcome, welcome. Thank you all for coming. This is the pain-free, stress-free way to create and execute a successful DR plan. I want to start off with my agenda this morning. How many people left last night with some red hair? I spent hours getting my hair done last night with some red locks. And I wanted to wear them this morning, but they prevented me from doing two things. I couldn't shave, and I couldn't wear them here because those spikes dug into my bald head, and it hurts a little bit. I have some marks here that would have probably started bleeding on all over the place while I was up here. So take note, keep your hair, or put some cushions on those things for next time. My name's Harry Smith. I come from Zerto. Been here for about 14 months. I started a couple of months before ZertoCon last year. And before that, I was at VMware for a little over 8 years. I started in professional services from a consulting partner, and then into VMware, doing architecture, which included everything, the basics, the vSphere architecture, data center migrations, P2V migrations, V2V consolidations, all that fun stuff, and then migrated my role into tech marketing under vCloud Director, documentation, implementations, and slowly into the integrated suites BU, helping customers understand when you buy more than one of those products back then, there's no manual on how to use it and go through upgrade processes, for example. So, and then before VMware, I was in IT. I started from desktop support all the way up through to data center administration and some hosted environments before it was really called cloud. Back in the early days of VMware stuff too, before VMware. But today's agenda, we'll get started. I definitely want to keep this open. If you have, it's pretty high level in some areas and deep in other areas, but we'll go as deep as you want. And if you had specific feedback you want to share, I've heard a lot of good things this week alone around what customers are doing and seeing and changes and challenges they've come into when they're planning the DR plan. And part of what we wanted to do this session for was, how many people here have used Zerto to do failovers or failover tests? Quite a bit, and the rest of you have probably seen it, right, at least? Probably a demo. If not, I'm happy to give you one outside after this, so come on by. Clicking that button does a lot of things, and it moves your workloads really, really quickly, easily, and gets rid of a lot of that stress. But it's not all that you need to do. There's a lot of pieces around that before, after, and ongoing that you need to consider, and that's really what this is all about. It's not a Zerto sales pitch, but I do want to get into, in the intro and overview, some of what the product does so you can understand what's in there if you are using it and what it can do for you, but then jump into all those other pieces. So everybody here is from different areas, different avenues. Definitely chime in and share with everybody what you found, some of the new stuff coming out that people are doing, and limitations and challenges and physical hardware that cause some issues or something like that, so we can all move forward and share this together. So we'll go through failing it over, and then what happens after that, and then partial failover considerations, right? You always plan, especially when you're talking going from the backup mentality to disaster recovery mentality, you're planning for that huge disaster, what I like to call the smoking crater disaster of you lost everything, so you fail over. You have BCDR, you have your business continuity plans of how do users access the systems, can they work remotely, all of those pieces. But what about failing over partial data centers? What about all these other scenarios of disasters hitting your environment? And how are you planning for that? How are you going to accommodate that? How are you going to redirect users? How do you get back once you're there? Can you have a strategy to reprotect? So let's dive into all of those. But definitely interrupt anytime with questions, and I think we'll be good on time. So if we find that we are getting too many questions and it's derailing us, we'll just try to table some and talk about it right after this at 11 o'clock, all right? So ZVR, how, where, and why. All I'm showing you here is the Zerto test network option, right? So how many people can use the test network option today? It works okay for most scenarios, and I know it doesn't work in every scenario, but it's very important to understand what that means, that you have an option on every VPG creation to have a failover or a move network, so when you're really moving your workloads or failing them over, or if you just want to test, you need to make sure those networks are created ahead of time. Make sure they're isolated for multiple scenarios. If you have multi-VPGs, and of course this is showing some of the one-to-many features, but the real reason around that, even without one-to-many, is what if I want to fail over a virtual protection group, a group of VMs that make an application? just for testing. I want to make sure my DR plan is working. Maybe it takes a re-IP and boot ordering and those VMs coming up correctly. Well, what happens in the top left there, the 3 and 4, those two blue ones, that could really be showing VPG1 is my full failover of the application. VPG2 is, 3 and 4, maybe I want to split that VPG and see how partial applications behave if I don't have all my workloads failing over, if maybe my data has been moved or my web servers have been moved, my data's not. So what happens when those are separated? But usually the scenario is the other way around, where if those two are my initial VPGs, 3 and 4, replicating locally or somewhere else, what if I want to fail over 2 at the same time? And they're on testing networks. I've created all these testing networks and they're isolated from each other. How do I actually make them communicate? So when you're planning out your networks, whether you're using stretch networking or any of those pieces, ensure that routing is available. So VPGs actually can fail over and communicate. You don't want to fail them over and have them all on their own individual networks if you need them to communicate. And part of these pieces I'm talking about, my history at VMware was building private clouds with vCloud Director and Lab Manager before that. Any Lab Manager customers around? Anybody heard of Lab Manager? One. It was a long time ago, and there is a cult following for it, but not here. But it was very important for dev test to have all these network isolations, and that's where they bumped into a lot of roadblocks was what happens when I need something else, something external or access to someone else's environment and application so I can do integrated testing with my application. Well, the same thing happens in a DR plan. I might need to test specific failover functionalities, but also that integrated testing of if this data moves, can it get to the rest of the data? So testing pieces is okay, and that can check off a lot of boxes of compliance, but you have to test multiple scenarios, right? So whether you're splitting VPGs, connecting VPGs, you need to understand all of those different types of tests and the types of networks you have to configure and set up ahead of time to access those applications and workloads. And then there's the infrastructure. We have our services, our domain services, DNS, DHCP. How do I test against those? So of course, even with network isolation on the other side, you want to have access to Active Directory if you use that and DNS services and all those pieces. But we don't normally want to replicate our domain controllers. We want to have another copy over there, right? Running for DR purposes if all your services need to be up and running over there so you can fail over quickly and connect to everything. Or you have to be able to build it on demand if you can. But we also do recommend, if you can test in an isolated network, replicate those services anyway. Yeah, you'll have a copy you're not actually going to use in DR, but you're going to use it for DR testing. You need to have that as part of those VPGs maybe, or you need to have, back to the previous slide, access to those networks so it can be routed through, but not routing out to production in any way, shape, or form. On top of that, a huge challenge people have is getting in and getting out. How do I get access to these servers? How do my users get access to those servers? Maybe they're not admins, but the application owners have to get in. So all these considerations around when you fail over, it's usually easy to get them access and have them get into everything, and you're probably used to doing that. But when you're testing, you have to spin up something for them. Maybe it's a proxy server, maybe it's another desktop that's a jump box for them. And there are multiple ways to accomplish that, whether it's through a portal and links into APIs, or it's actually an interface that they have to have access to if you have a cloud portal front end or some type of virtual desktop environment. But all those directions and communications of where everything needs to go absolutely has to be considered, and testing can be some of the more challenging than actually doing a real failover, right? But you have to stay compliant. Something that was really, really big that I heard from a couple customers this week were they can do failover tests even with the Zerto product, or whatever solution you use, as long as you can test it, that's great. But they were able to do it, but it still didn't meet all their compliance standards. Does anybody have to do additional testing above and beyond failover tests to meet compliance today? We have a few in the room. What are some of the reasons, some of the limitations around failover testing that you're seeing? Anybody want to share? Okay.
And the logging functionality built into the Zerto failover test does not log results or execution output of the script.
Okay.
All prior or post
So running failover tests with those post or pre-recovery scripts doesn't provide you enough logging built in.
And if you have any kind of system that has to have DR audited by a third party, they ask what your job was.
Yep, yep. So are you able to put wrappers around your scripts to inject it into post and pre-recovery scripts in the product, or do you actually just call failover test externally, or you have to do live failovers to accommodate that?
Well, our workaround as we're moving into using Zerto more often is to just make sure that the output of the script jumps to a text file that we can then append as an additional report. But it would obviously be more elegant if there was something in the Zerto
Perfect.
API to accept that output.
Okay, yeah. Okay, so maybe it's a limitation in some product that is forcing you to try other ways or mandating other ways. So do you do both, some failover tests for certain compliance tests, and then you have to do external tests as well?
No, it's just we have additional processes now that
Okay.
we apply. I mean,
Okay, so you can still get it accomplished. Good.
and it'd be nice if it was an all-in-one option so that I just one button and everything's complete.
Yeah. Anything else that's causing, you want to?
Ours is more for SLA enforcement. We will require, we're a cloud service provider. We require our customers to perform a managed failover test and a failover annually in order to qualify for.
Annually, okay. Okay, good, good. And to match what SLAs are providing to them and prove it out completely? Okay, awesome. So yeah, those are huge pieces. There are other pieces that sometimes you can accomplish with failover tests, but sometimes it gets a little more challenging. The physical layer. I have many, many customers. I mean, you can speak to a solution like a Zerto or a solution like virtualization, and sometimes Zerto is a solution, or your BCDR strategy is a solution to get more workloads virtualized because of these advantages of what you can do and test. Because it's extremely difficult to test physical servers without a real live failover, right? Without failing over to another environment, unless you can put those physical servers on a test network temporarily and get all your routers and switches connecting into those failover test virtual machine groups. Is anybody able to do test failovers without live with physical servers today? No, it's in some way, shape, or form you could accomplish that. Is that keeping specific DR workloads that are replicated in, or is that real live DR servers that you can isolate for tests?
Yeah.
Yep, awesome. Yeah, so you can accomplish it, you just need that process, right? And I think it saves a lot because there are so many times that people have their testing once a year, maybe once a quarter, but it's DR weekend or DR week where everything has to come down and put a code freeze, and everything you do, you're stopping production workforces so you can actually fail over and do a real test and test those physical layers. What happens if my data is still physical? I have these huge databases I just don't dare to virtualize yet, or the vendor's telling me I shouldn't. So maybe we don't have the time to test them as virtual machines. So you might have to do real life failovers. And that's also the physical layer when you're talking about networking. Does anybody have virtualized firewalls that they can test with? Are you running virtual firewalls, or is it all physical? Some virtual, everybody else all physical everywhere? So you have to, if you need to test against that for compliance, because no matter how many times you can say it's all going to work, I know those rules are all loaded in there. My ACLs, my routing, my switches, everything's built. Sometimes for compliance reasons, you have to do a real failover because things still go wrong, right? I've done 1 million data center migrations where something was missed, no matter what happens. It doesn't mean it's a lengthy problem and it's a hard fix, but something's missed and it causes time, and that adds to RTO. If we want to get RTO lower and lower and lower, and products and solutions can make that minutes or 15 minutes or a half hour, you don't want to add 2 hours of troubleshooting just because of one simple problem you could have fixed. So sometimes you have to do physical testing and live testing. So gathering all those requirements and determining what all the impacts are to live testing. What type of outages are you taking? Is it a maintenance window? Are you causing downtime? Or can you have duplicate services running so you can actually do a test while live workloads are still taking over, splitting your workloads up and making sure that users can still access the systems. And what impacts does that have to the business? What impact does that have to the customer? And all the operations around. If you have huge entire teams working on this, you're taking them off their day jobs too, probably. And it's usually not the new person doing that, clicking the buttons for you on a live DR test or a failover. It's not the interns that you put on that. It's your top tier architects or engineers or whoever you need in there are off their day job doing this. So there are a number of impacts that cost the business a lot of money. If that's what you need to do to meet all your demands, that's okay, but just understanding all those requirements. And how it actually works when you're failing over, when you're going through the physical layer and all your physical firewalls and timing all of that. So a big problem with data center migrations, I mean, I know this is a DR plan, but the same holds true for data center migrations. You have to plan that strategy of actually moving workloads, shutting them down and bringing them up. So it's the same process, but timing is a huge problem. Timing of your actual resources. I remember so many times that I was trying to migrate workloads, shutting them down, failing them over, and bringing them up somewhere else. And I can't do that this weekend all of a sudden. There's something hot. It's maybe political reasons, or maybe there's a project going on that just can't be stopped. So all of that timing around what happens is critical, but also the timing of how to bring those workloads up. Because when you're doing a real failover and you're in an actual disaster, you can't plan for that anyway. Even if they have, this disaster is not working for me this weekend. Could you hold off on that and make the hurricane go around us this weekend? So you're not really timing those resources in a true failover. But you do have to plan for all those firewalls, all the different rules you need. If you're changing IPs, show of hands of how many people have to change IPs versus stretching their networks. And it's a challenge. It can be a real challenge. There are many different ways to accomplish that. And people leveraging stretch networks to make their life easier, is that working out? Are you hitting headaches because of that? With routing traffic, once you've layered that with management of those stretch layers, because sometimes those are some of the issues where best practices say, let's try to stay away from stretch networks. Anybody hitting problems that they've had to work around because of that? No?
So we're sort of in between. We've actually built the same network structure at our DR site to mimic a production site, so it's still a totally separate IP scheme and dealing and everything.
But identical?
So when we're doing testing, it was good to hear that we're kind of on the right track, that we got the routing built between those test networks, but they're still isolated from production networks. And then the real disaster, we're planning to tear down or actually build the routing to allow us to talk to production networks from that point. One of the challenges we're having, hopefully we'll get there through this discussion, is allowing external access, like access from those test networks out to an external resource, or the internet or something like that. I'm curious how other people are handling that, poking holes in that wall, so to speak.
Yeah, so that's a really common problem, and sometimes it's really difficult to solve. So even when you're talking DR testing, and if you couldn't hear that clearly, he has an isolated, complete, identical duplicate network on the other side. So first off, before I jump into that, how long does it take you to fail over that process of rerouting? Is that a lengthy process? Is it automated? How many steps? How easy have you been able to make that?
We're still building it out, but my network guys tell me that it's fairly quick to make it a live network.
Yeah, good, good. Yeah. So with DR testing, sometimes you can't get out to external resources. It depends on what that means. If external to that application is still internal and it's going to cause updates, that's when you might need to duplicate, replicate your domain controller, replicate those services so you're not actually making DNS changes. If you need to change an IP or change a name, you don't want it to actually update and replicate back, or you need to have one-way replication in between all those services. But I've seen a lot of times, even internally within Zerto, application developers, the same mentality where you can stub services. So you can have our UI, for example, doesn't actually have to hit out to a live vCenter because they can mimic that and make it look like it's hitting that vCenter and getting real data back. So if that meets your compliance needs and what your business requires, then that's actually okay. But if it only meets so many requirements, then you still might have to do that real live failover test to encompass that service, or build it again a second time. So take those resources and get them replicated in so they're identical, and then spin them up. Maybe even if that's the type of scenario where you can stub off some of those services or cloud-like functionality, you can actually nest those and virtualize them, even though they're physical in the real world. Maybe you can virtualize it. But the more and more changes you make in that area, especially with software development, applies to a full DR test is you're making more and more changes, and it's more and more or less and less like production, right? So the less it is closer to production, sometimes you run that risk of not meeting certain compliance standards depending on your business and your vertical. So I'm sure some people in the room that are in those verticals can talk about all those things you actually can't do. So you have to actually do some of these physical failovers and live failovers. Yeah, go ahead.
Just with regards to some of the timing, we're a group that came looking at sort of, we haven't actually purchased as of yet, but do we have anybody here that's doing failovers to multiple sites of maybe a particular engineering application or just a set of VMs? And how long does it take for that, for the bits to catch up when you're moving from one site to another to another?
Are you asking about failing over an entire site to different sites, or a site split between multiple destinations?
Split, or let's say that you're doing a test. We have kind of a scenario where we like to have a specific application. We take those servers and move those servers to another site. Here's your DR test. We're done.
Right.
Now it's going to live there for a while until we move it back or we move it somewhere else. But let's say you were doing one jump and then another jump. Is there a concern about bits catching up, and if you actually have an incident during that, what happens to the final product?
Sure, and it definitely depends on how many pieces you have in your environment that are virtual, not virtual, and those layers. But yeah, go ahead.
I have probably 50, 60 customers using the product, and some of them fit some of those scenarios there. Most of the time, the conversation we have with customers is how much bandwidth do you have? Because that's usually the bottleneck. Sometimes it's disk I/O because it's not able to compute the Delta syncs fast enough. But usually, if you've got enough bandwidth, it can be a very fast thing. I mean, it's actually what you're talking about is very similar to just moving, not necessarily it's moving with
Right, right. With a reprotect, yeah.
But you know, it's easy to move. We move data centers, no problem. We take a 20 terabyte network with a gigabit uplink, and we're reverse syncing the same day. And you know, yes, there's some risk for the few hours it takes, but if you've got the bandwidth, it's actually really.
Yeah,
It's like we'll have customers that go, "Wow, you just moved my 20 terabyte data center, and I had a 5-minute outage."
That is a huge use case, yeah, absolutely, is being able to do that, because I've done them using a Zerto or an SRM or any of those products that can help with that automation, and it's days of outages, not minutes, under an hour, certainly not. Sometimes you can do an hour or 2 hours in the virtual world with certain applications, but it's challenging. But exactly that question and answer is around the resources and the timing of, not only do you have the resources, the bandwidth, you can test that ahead of time. You can monitor what your throughput is and what the requirements are and size that. So you get a pretty good idea how long it's going to take. If I need to meet 15 minutes, this is how big my pipe needs to be. If it's not, we're going to prioritize. Maybe I can do partial and move some to still meet 15 minutes, but not 15 minutes for everything. But also resources on the other side, the hardware. If you're repurposing hardware, you're repurposing servers or storage, that's perfectly fine. But what does it mean? Does that same hardware have to run 100% of your workloads all at once? Or is it only running partial? So if it's half the capacity and half the horsepower, maybe it can run half the workloads or 40% of your workloads, and that's okay. So it's okay to repurpose, but keep that in mind of actually having the horsepower to do what you want and for the length of time you need. Some people think disasters, I'll be out, but I'll be back in 3 days. Sometimes you cannot get back in 3 days. Something's causing it. If it's weather related, and you just don't get power back for a week, but what if something happened to your data center and you just can't get rebuilt, you can't get hardware ordered, you can't do something? You have to plan for an extended length of time in the extended stay hotel. Maybe you can get a month out of it. Or maybe you can leverage some cloud resources to augment what you might have for a data center. If you know that time's going to hit a certain area, maybe you can burst out and take advantage of some of the clouds and expand your resources and horsepower that way. Or you tier your resources, so when you're in there, you can bring up, I need more resources all of a sudden. It's just a few clicks, and you can size things more appropriately, quicker, more easily. So maybe that helps. We can definitely dig into detail of that after this too. around that conversation and what people have hit. But then that devices conversation comes back to what you were saying about users getting access. If it's mobile applications, you need to get them tied into that network. So if it's hitting an external IP address that can tie in to a back-end test network, you have to figure out how to refresh those devices so they're pointing the right way, or educate the users on which, maybe you have a failover application, a mock-up on the device, and you have a real, and they can hit that one and it goes into the test network, but you need to see the traffic coming in and route it to the right way, and that's perfectly fine. So you can get in. It's the same thing of getting into an isolated test network where in cloud environments, you would duplicate everything. So you have 100 or 200 of applications exactly the same with the same IPs, but you don't give users access to that infrastructure. You give them access in, and then those machines are routed into their isolated networks perfectly fine. So when you're running those hands-on labs and things you see here, that's how that stuff runs. It has to be very easily accessible and brought up, so you can do those full tests, but you still need access in. And you're going through a web portal. You're going through something that isn't how it normally might be in production, but it's still the same thing, and you have access. It's isolated. That is technically a DR test of a real application that's been virtualized and is in its own bubble. So you can get your users in. So there's a lot of best practices around that and how to poke those holes. But again, I said if those resources internally need external resources, they need databases, you have to figure out if you can have dedicated hardware or isolate the networks for the physical hardware, physical databases or storage or something. Or can you replicate that data from that physical database server into a virtual machine and get a copy of that into your bubble, test it. Maybe you can take a subset of the data because it's a 20 terabyte database and you don't have space. Maybe you only need 2 terabytes of data for this test. So what application are you trying to actually test and how robust can you be? So it all comes down to resources and can you split that off somehow to accommodate what you really want to get done. If it's not a full functional complete site failover, you can still accomplish a whole lot of other things, but there's different operations and different considerations in networking. So again, access, we talked about how does this actually happen when you fail over, and some people have mentioned this already, but your global load balancing versus local load balancing. What are you trying to protect against and what do you need running? Bless you. This changes depending on your application footprint and behavior, characteristics of your application and what they require. Web servers can be load balanced and they're very dynamic and they can grow and shrink and burst. So you have different considerations around how you protect that. It's not so much work. Or you might be building your application to be completely redundant for local load balancing, for high availability. So if something goes wrong, it's a pool of resources, a pool of data, or a pool of web services or file servers or whatever index servers they are. But you can architecturally build that in for redundancy and high availability. But when it comes down to the management layer, for example, on the right side, the architectural redundancy and high availability, we often get a question of protecting VDI environments, right, or cloud environments. You can do it. There are challenges around it. We don't recommend you protect everything with this solution, and there are very, very few solutions. So when I worked at VMware, for example, this isn't specific to Zerto. It's specific to the challenge and the architecture of the application. I had the fun task of, back in vCloud Director, how many vCloud Director customers? Nobody. Cloud, yes. So it's a management portal and cloud front end for all of your underlying resources, right? All these virtual machines. And these virtual machines have certain characteristics, but the management layer is actually the easy part to protect. To duplicate your management layer or replicate your management layer, that's great. But it's all those pieces underneath. These virtual machines have link clones and different characteristics of how they need to map to certain things, and you can't replicate those workloads. They're oftentimes dynamic, just like a virtual desktop pool. Who's virtual desktops? Anybody? Those pools are usually dynamic. Sometimes you have static desktops going to users. But if you want to have a more robust architecture, you might start backing away from that dynamic nature of one-to-one mapping and make more dynamic pools, not that static nature. You want users to be able to spin up from anywhere, so you've rebuilt that management layer, that architecture for high availability. So there's a second set running on the other side. VMware has best practices around that, and Microsoft has best practices. So that virtualization layer, you can accomplish that to say, this is how you build it here, this is how you build it over there. So no matter which site you want to be on, you can spin up resources. But now if you've mapped those characteristics of the pools of those resources to both sites, it doesn't matter which site you're accessing, it's going to spin up what you need incorrectly. If you're talking about static mapping for a user, so when they log in, they get the same exact server every single time, that's when it gets more complicated and you have to actually replicate that server somewhere and then tie it into a different pool, which is very challenging, sometimes impossible to do. So think about your architecture of the applications and how you're actually building it and might be able to rebuild it, because that application can probably stand being hit if you've built it that way to certain disasters. When you talk about journaling and point-in-time recovery, I wasn't going to dive into this, but having high availability protects you against that sudden loss, right? But when, of course, when viruses or ransomware or anything else comes in where you have to go back in time, that gets a little more challenging. So that's only a piece of the puzzle, but you can build your architecture and your application to handle those types of disasters and get you more uptime with fewer steps. But how do you get access? How do you get users over there? If you're doing stretch VLANs, that's excellent. Some solutions don't allow you to have multiple management interfaces, or they're all running on one site. So if you lose connection to that site, you're kind of out of luck and you have to do a lot of rebuild, again, adding to RTO. I'm just checking the time here. So you don't want to keep adding to RTO, so you have to figure out all those services that you have to update. You're addressing the caching and the gateways and timeouts and maybe round robbing your network. So if that goes down, we'll notify that and we'll flip you over to another IP address so you don't have as much outage window. But if not, you have to figure out how to reroute all those IP addresses to the other side and which services you're going to use. Maybe you're using a global DNS provider or services for all these networks. Or you have just duplicate gateways yourself or VPN connections in, but that requires other layers and instructions to your end users of when you go down, these are the steps you need to take to actually connect in through the other VPN and make sure you're using these application links that say /dr site. But it's a whole, even if everybody has the operation and the procedures, it's still going to be habit. I still do things where I know I'm using this new system and someone told me not to use this old one anymore, but I forgot the next week and I'm in the old system. So just to tell people, hey, use the other link, doesn't always work and you're going to get a lot of support tickets. So this duplicate gateways or VPNs may not work. You may need to rely on these global cloud services to keep your business up and running, and they can manage that failover for you. So there's a lot of things that go into building that. And one of the last pieces of that is communication and tracking. Like was mentioned earlier, logging all your tests and what's going on. But can you track everything you've done? First part is communication. Updating your website, communicate to customers maybe, we're experiencing this outage. Maybe you don't have to do that because your web services are completely redundant and your DNS automatically updated. But if it has to update caching servers around the world, globally, it might take a really long time. It might take a couple of hours. It could take up to a day, depending on where that customer is coming from. So you want to keep them up to date. You want to update all your internal organizations that are part of that dependency and update your customers before, during, and after. That's key to your business and your company image, right, to the external customers and internally of how fast you can react. Something that might even be out of your hands, you don't want that to come back to you. Hey, IT couldn't do their job, or this company couldn't fix this. Just communicate what's going on and what you know and what you don't know and what the expectation is. And track it and log it. So oftentimes you can work with your providers, whether you're private, hosted, managed, public. The differences in those of running your own, and most of those areas we've touched on are private, but of course they apply to CSPs and to hosted providers. Hosted, of course, if you're doing hosted providing, you're putting resources somewhere else, and maybe they can manage some of the services. Maybe they have control over servers and services that are going on inside. But maybe it also means you're sharing services. I worked at a hosted provider a long, long time ago, and oftentimes customers at the lower tier of paying structure shared services. They were virtualized and sharing a domain controller or sharing one physical server for all these virtual machines. You don't get dedicated hardware sometimes. So when you fail over, can you completely fail over without impacting other customers, or are you sharing certain things that you can't move? But they'll manage some of the services for you, like DNS maybe. But that's when you start going into the managed clouds and the CSPs that actually provide a service, the service providers. They say, just put your workloads here. We'll either let you know when you have an outage, or you let us know, depending on what we work out and what we can do for you. But you're clicking a button on your solution, we're going to click a button on the other side. Your button is just letting us know that you want to flip it over because someone needs to make that decision. You don't want to automate everything. because sometimes you just actually need humans to talk about it and make the decision first. But the managed provider can do those things, those global updates to all your addresses, those switching over physical workloads or virtual workloads, and definitely feel free to add color to all those things that a provider does if you're in the room that you can help the room with, because there are so many pieces of that list that you have to keep track of, and you might only test once a year, you might only test maybe never physically, maybe you do virtual tests all the time and you never physically do it. So even in the case where customers are testing once a year at a service provider, that service provider is working with hundreds or thousands of customers doing it all the time, even once a year. So they're doing it every single day. So that's a team of DR experts that provide that as a service. So you don't have to rely on your experts that haven't touched it in a year. You can rely on experts that touched it 3 hours ago. And they're actually managing that whole process. Everything comes up more smoothly. They have a lot more compliance standards and strict requirements to give you those SLAs, or they're going to have to start paying you money. So there are some advantages to going from that, making that jump from hosted, where you still have to do a lot of the work yourself and understand all of that, to managed, where maybe that cost, it looks like it's more, but it actually ends up being a lot less, because not only are you not managing and maintaining the hardware, but you don't get extended RTOs because you're out of practice. And those RTOs are actually more costly usually than licensing and hardware maintenance and management. And then the public cloud. How different is it when you're trying to get into public cloud? Managed providers and hosted providers can oftentimes give you visibility. You have to find that out. What visibility do they give you during the process of outage? How's my replication status looking? Can I get access to that and look at it and look at logging and see all those things that are happening? Can I get in and help manage the process? So while you're doing it, I can make checks and balances and make sure everything's going correctly, and I can help manage that process as we're failing over and getting access to it. Are you going to provide me a proxy server into tests? Am I being able to get into my network? How do I route that back to my own environment? They can walk you through that. So it's those pieces you don't have to figure out anymore. They'll just tell you the requirements you need and how to do it to get into their environment. And when it comes to public cloud and places like the Azure cloud or Google cloud or Amazon and all these ones that you don't have as much visibility into, you start to lose some of those pieces. I'm not saying that's good or bad. Maybe partial failover dictates that some of it can go to the cloud for certain tests because it's a cheaper alternative for you or faster or whatever. But there's different requirements for that application. It doesn't have sensitive data, so it can go into certain clouds. I'm not worried about it. But I still need accessibility. I need to know about the process. I need to make sure my express route's going up to Azure or something, a VPN in, so I can test certain things and isolate users. And ensure everything's going to always be up and running. We only have a few more minutes left, but only a few more slides, so we're doing all right. Partial failover considerations. How many people have to test partial failovers today and do test? We have a few. It's easier or harder than full? Same? Different? A little bit? Yes. Yes. But it's documented known, so you can still successfully pass your test if you document what processes are expected to fail, right? So that's okay. So yeah, that's exactly it. Excluding processes, expecting failures, or stubbing processes so they actually look like they're succeeding and they're successful to the application. Is great, and that's what gets really, really tricky with an enterprise when you're talking about even virtual protection groups or protecting a group of servers as an application. They're so intertwined, all your applications are. You almost need to protect everything together anyway because of that problem if you want to test everything. And you don't find that stuff out until you move. You do a migration or you do an actual failover to say, oh, I didn't even know it was trying to hit those. So you're moving part of an application over. Do you want all the application servers and index servers to fail over? Where they have a very, very low tolerance for latency, but the data's still back at your main data center that they're trying to hit, because you didn't know it hit this 15th database. It was hitting these 14 that I knew about, but I didn't know there was a 15th one with data in it. So I need to capture all those databases. I cannot have that crossing across the world to get that data and populate it for the users. So it depends on your application and the thresholds that it's available and able to do, but how do I move some of my stuff to different areas? How do I move my DR site? Maybe it has 50% capacity, so how do I get some of it to the clouds? And which pieces do I actually move to keep that latency lowest for those applications. If more can tolerate higher latencies, or you have a bigger pipe to other data centers and other clouds, and even providers can do that, they can have SLAs for how much throughput and bandwidth and service you get in those. So you can figure that out and map your applications that way to say, I need these applications to move over to here, and these can go up in this cloud, these can go over to here, these have to stay on-prem just down the road. So you're mapping out all of those different types of disasters. There's so many use cases of disasters, it gets kind of scary actually. But it comes down to that operation, those checklists and those steps that you have to take into consideration. But where's my data live and where do my servers live? Where are they actually running? Can they fail over from physical into virtual workloads? So then when I want to come back, I can bring them back virtually or bring them back to physical. Can you do that? Maybe it's okay for test to fail over to virtual. Maybe it's not. Maybe that actually tests helps you virtualize applications too. If you need to move to a virtual, more mobile and agile environment so you can burst into the cloud, testing it into a virtual layer gives you that data to say, yeah, this actually runs better in the virtual environment, and I have more visibility into it than physical. So it doesn't have to be scary, but it can help you move to that next level and move through those clouds. So that split brain scenario of if something moves and I haven't accounted for firewall rules because I didn't know, then I'm troubleshooting that. I have to troubleshoot fixing the firewall rules and then testing that latency. And you don't want to test that during a disaster, because that's, again, all RTO, that you're spending time doing that instead of failing over the rest of the servers. So how do I find those other servers in that tense moment? Everybody's stressed out, trying to figure out which application server or database server I need to move over now, and how long is that going to take? I didn't get the data prepped ahead of time. And which replication strategies am I using? Do I have different windows? Do I have 15-minute replication and 2-hour replication? And how do I match those up and make sure I'm not split brain between my data points and sets and point-in-time recoveries? So you have to manage all of those pieces, and it gets really, really challenging. But it's more about the awareness. Again, if you know what's going on and you can check those boxes and make that process every single time repeatable, if it's this type of failure, this is my runbook. Anybody can follow that runbook, either call the right people or click the right buttons, and it's done. It's done right every single time. So you need to be able to get back. You want to go up. You don't want to be locked there. You want to be able to come back again. Maybe you want to go up and stay there, and that's okay. But once you get somewhere else, you need to have protection. If it's a reverse protection or setting up protection again to another cloud site, to back down to your site, you need to have reverse protection. And sometimes that's not completely automated. Yes, products like ZVR do automate reverse protection, but that's, again, for virtual workloads. What other pieces do you have to think about? Do you now have to think about those firewall rules? Okay, I thought about how to map them all to that site, but now what do I do when I want to switch back to my main site? I can't just turn everything on. Maybe it won't work. Maybe DNS doesn't route the same way, or maybe something else needs to happen. So you have to be able to reverse protect instantly, because as long as you're running up there without protection, you have another DR outage, a potential window there that you have no ability to actually get workloads up somewhere else. What if a disaster happened again a couple of days after you moved and you haven't protected yet? So figuring out all those pieces of how to reverse protect, but document all the steps, schedule it. So when you want to actually maybe you want to get back to your main site again, you don't want to stay where you DR'd over to, you need to schedule that. You need to map around all those projects upcoming. You can't just say, we're doing it on Friday. It might be a partial move back. You can do it more gracefully. You can plan that out. I can move this application this weekend because those end users are ready for me and they can take the downtime, the outage. It's not end of month for them. So I'm going to schedule the partial failover for them, taking into all those considerations that I already planned for in the DR strategy of what happens during partial failover. What do I expect? Do I have split brain? Do I have latency problems? You can plan that now. You can group it and start failing back maybe slowly. And then update all your global DNS routes and all those pieces again, but you already have that process down. You just have to reverse it. Which servers can I move and which services have to be up and running over there to accommodate that? I'm not doing a global update of all my DNS now or all my servers. I'm only doing partial. So how does that map in? And which you don't want to check the wrong boxes, so you're actually mapping the wrong ones, and then users are going to DR servers that has old data. You need to figure that part out and make sure those boxes are checked appropriately, because you're doing a slow stepping stone failback to your main site again. So all of those pieces you have to follow and map out. And then once you're back, reprotection. It should be as easy as the one you set up the first time to protect your DR site, but make sure you can test that. Make sure you know that if you need to reprotect, everything is actually there and all the steps were taken. You didn't miss something, so you're actually worse off than before the first time you protected in the first place. So we're out of time, but if anybody has anything they want to talk about after this, feel free to step around. Thank you for giving your input back too. I think it was extremely valuable. So thanks for coming, and enjoy the rest of the show. you.